Let's start with the probability of y or a. Now there are two ways to get this. The first is to get it from the interior of the table. The event that a customer is young is from these two cells. The event that a customer had an accident is from these two cells. We can see then that there are three cells, 1,000, 250, and 200, that are contributing to the probability that a customer is either young or had an accident. Now we can get this, the probability of young or accident, from the marginal distributions as well. What would be nice is if we could simply add the probability of young plus the probability of accident to get the probability of young or accident. But it doesn't quite work. The probability of young comes from the accounts of 1,000 and 250. This is young. And the probability of accident comes from the counts 200 and 250. Here are the cells for those customers that had accidents. If we simply add these up, the 250 will appear twice in the sum, whereas the correct sum would have the 250 only once. So what we are going to do is to add these two rows and then subtract out the count that gets in there twice. In terms of the arithmetic, we need to add this sum plus this sum and then subtract out the 250 over 3750 once because it's now in here twice. In terms of probabilities, this is the probability of young, this is the probability of accident, and here is the probability of young and accident. 250 is the one cell that gets in the sum twice. We remove it once, and we're left with the correct sum. There is the sum that represents the probability of young or accident, and it comes from the marginal distributions, young and accident, minus the one cell on which they overlap. Add the two simple probabilities, subtract off the intersection. All right, let's do another example. What is the probability that a customer selected at random is either mature or had no accident? Well, the sum rule tells us this. The or on this side generates the simple events, probability of mature, probability of no accident, minus the probability of the intersection of events, mature and accident. It's important to remember that the or occurs on the left, the and occurs on the right. These two come from the marginal distributions, mature and no accident, 2,500 and 3,300. Subtract off the probability of mature and no accident. Mature and no accident overlap here at 2,300. And there's the probability of mature or no accident. Now just to check, we could do that directly from the interior of the table. Mature or no accident comes from this cell, that's mature, this cell, that's both mature and no accident, and this cell, that's no accident. Sum them up, 3,500 divided by 3,750, which is exactly what we got by the sum rule. Well, our instructions then say to compute all four of the or probabilities from the table above. We've done the first two, the probability of y or a, the probability of m or a complement. There are exactly two other possibilities. the probability of y or a complement, and the probability of m or a. The sum rule tells us this. The probability of y or a complement is the probability of y alone plus the probability of a complement alone minus the probability of their intersection. The probability of m or a is the probability of m plus the probability of a minus the probability of their intersection. You should get these on your own and then double check by looking at the interior of the table, just as we did with these two.